So, one of the big things that your body has to do is maintain itself, and it needs to keep itself healthy. The mechanism by which we maintain ourselves is called homeostasis. And you are probably familiar with homeostasis because you talked about it in freshman biology. And while freshman biology kind of talked about it in a very basic sense, there are some things that you may not have gotten in freshman biology that I want to make sure we cover now. Because basically every body system has to do some kind of homeostasis activity. It's doing some aspect to keep the body healthy. So, one of the things that you may remember from freshman biology is that most homeostatic pathways are negative feedback loops. What that means is that the response inhibits the stimulus in some way. So let's talk about what that looks like. First, we have the stimulus. This is the change in the body. The receptor is there to detect the change. Then it relays that information along the afferent pathway to the control center. And the thing you should probably know about the control center is that 9 times out of 10, the control center is the brain. Most of the time, the brain is the one receiving this information and then coordinating the response. The brain or the control center is then going to send information out along the efferent pathway to the effector. The effector is the thing that is going to create the response. And so it's the thing that is going to release whatever we need to secrete or whatever intervention we need to bring about, the effector is going to do it. And then finally, we have the response. The response is then going to inhibit the stimulus. And these pathways usually come in pairs. Usually we have a situation where we have to respond differently if the stimulus varies in one direction or the other. And that is really important for protecting the body. An example of that would be like body temperature. We don't necessarily want to have the same intervention if the body is cold as if the body were warm, because those are two very different things that need to be responded to, although they both revolve around body temperature. So if the body increases in temperature, we go along the response pathway and then we release sweat as a way to cool us down. On the flip side, if we were to do that same thing, we would just exacerbate the problem. If we were already cold and we started sweating, that would exacerbate that problem. So it's really important to recognize that these come in pairs so that we know that the responses aren't necessarily going to be the same, even though, the problem may revolve around the same like homeostatic factor, like body temperature. The thing that you may not have talked about at all in freshman biology is positive feedback loops. Positive feedback loops are where the response, the stimulus and the response trigger each other. So the response enhances or makes the response continue until something else intervenes. So this is how your immune system works. Your immune system works on a positive feedback loop. So should you have a broken blood vessel because you got a cut on your hand, the bleeding that we see is going to trigger the response for scab formation, and that is going to continue to accelerate the bringing in of platelets and the stimulation of surrounding cells to make the scab form. And that will continue to accelerate until that break is fully closed and we no longer have active bleeding. So I want you to make sure that you understand positive and negative feedback loops. And while most of the time we will still see negative feedback loops, because we are in anatomy, we will also see some positive feedback loops. So it's important to understand both at this point.